Crew Program at NASA's Kennedy Space Center. Joe Montalbano, Manager, International Space Station Program at NASA's Johnson Space Center in Houston. Mark Nappy, Vice President and Program Manager, DST-100 Starliner for Boeing. And Dr. Michelle Parker, Vice President and Deputy General Manager at Space and Launch for Boeing. We're going to begin with opening comments from our speakers, and then after that, we'll take media questions. First, we'll go to Kathy Leaders.
So thank you all for being here. Very exciting time. You know, we're continuing to safely move through our spring mission milestones, and it's very exciting now to be talking about our second uncrewed demo of the Boeing Starliner and the ULA Atlas V. This is a really important step in our continued goal of having, two U.S. crew transportation capabilities to the ISS. And as you know, robust crew services is really important to our sustained commitment to our research, the science and technology development that we're doing on the ISS, and it's critical for us meeting our exploration goals. I'm very proud of the CCP, Boeing, and ULA team that has been carefully getting their hardware ready while also resolving the issue that had interrupted our previous flow. The team's working and through their final reviews right now and headed toward our agency-level flight readiness review, which I'll be chairing on May 11th. So I know you're going to be excited to hear all the progress that the team's made. And to give the next status, I'll introduce Steve Stitch, the Commercial Crew Program Manager.
Okay. Thank you, Kathy. I'm really happy and excited to be here today. You know, it's an exciting week for us with our flight readiness reviews coming up on Thursday and Friday, and also with Starliner making its journey over to Complex 41 and getting it back to the pad. You know, it's very important to Commercial Crew to have our second transportation system up and operational to continue our assured access to ISS and also to grow the lower orbit economy. Super proud of the Starliner team and the NASA team over the last 8 months. It's been a hard 8 months, I would say, but very fulfilling that we've resolved the problem with the oxidizer isolation valves and we're headed on toward launch. You know, it's going to be an exciting mission on OFT-2, testing out the rendezvous system on Starliner. Also, the NASA docking system will be used for the first time as we dock to the ISS Node 2 forward port. And also, we'll have some dock operations to test many of the Starliner systems while we're docked to the space station. So a big, important test flight on the way to our crewed flight test. You know, every flight like this is a flight test, and I suspect we will learn a few things on the way, and we'll continue to improve Starliner as a result of this flight. You know, we spent 8 months doing a deep dive on the oxidizer isolation valve anomaly. You know, we have good root cause now, and it's been to the Program Control Board and closed out between the Joint Space Station Control Board and Commercial Crew Program Board, and we'll take that to Kathy on May 11th at the FRR. So we've closed that anomaly, and it's great to have that behind us. I know Mark will talk a lot about the hardware, getting ready to go fly. You know, the spacecraft is fueled. In the C-3PF, we have the service module full of oxidizer and hydrazine, and then, of course, the Atlas V is stacked and ready to go. We're working toward a launch on May 19th at 6:54 p.m. Eastern Time, and we'll have a backup on May 20th at 6:07 p.m. Eastern Time. Again, I'm very grateful to the NASA and Boeing team. They've done a great job over the last 8 months getting this work to completion. The astronauts on board, when we talked to them prior to launch, the crew 4 astronauts, Chell, Bob, Hines, Jessica, and Samantha, they're excited to see Starliner arrive very soon. And then just a little bit of a Crew 3 status. We are working toward an undock at 1:05 a.m. Eastern Time on May 5th, with a landing for Crew 3 on as early as May 6th at about 12:37 Eastern Time off the coast of Florida. The vehicle on orbit's doing well. We've inspected the thermal protection system on Dragon. We've checked out the suits, the displays, and the ecosystem. Tomorrow we'll check out the comm systems and the guidance navigation control systems and the prop systems on Dragon. We'll have a weather brief tonight, about 24 hours prior to the undock time frame, and we'll take a look at the weather and see if we continue to press forward. And that's all I had. And with that, I'll turn it over to my good friend, Joel Montalbano.
Hey, thank you, Steve, and thank you, everyone, for joining us for this mission overview briefing. Since we last talked, we've been focusing on board with the handover between the Crew 4 and the Crew 3, and that's going well. I've talked to the Crew 4 commander a number of times, and they are ready to take the helm as soon as we can find some good weather to bring the Crew 3 vehicle home. Last week, two of our cosmonauts also performed a Russian spacewalk to continue our outfitting on the multi-purpose laboratory module, an MLM, that was delivered last year, and that has gone well. And so we're happy to continue moving forward with activities. You know, as we look forward to the launch of the Boeing OFT-2 mission and the docking, I can tell you Space Station team is ready to support, and we're excited to have another vehicle on board the International Space Station. This mission is a major stepping stone for Boeing and NASA as we enable, like I said, an additional crew provider to the International Space Station, and we consider this a landmark flight. The crew on board will be monitoring the approach, and we'll be able to send commands to the spacecraft if needed. Going uphill, this vehicle will be carrying about 500 pounds of cargo and returning with about 600 pounds of cargo. Steve mentioned the launch time was 6:54 p.m. on the Eastern Time on May 19th. After this vehicle undocks, the team will turn their focus to the SpaceX cargo mission currently targeted for a launch on June 7th. So with that, a huge thanks to the Boeing team, the commercial crew program, and all my ISS colleagues as we continue focused and look forward to this mission on board the International Space Station. With that, let me hand it over to Mark.
Thanks, Joe. First, it's a pleasure to be part of the commercial crew program. And since I've been on board, I've been able to witness how everything's been coming together for flight. And I'd like to thank NASA for the partnering that has taken place over the last 8 months to work the solution since OFT's first attempt and to get us where we are today. This was a really fantastic example of how NASA and industry work together in the best interest of our space program. It's really impressive to be part of. As far as the vehicle status goes, we're doing our final preps today. Those will continue through the night, and we'll be in a position to do a crew briefing at about 0400 or about 4:15 in the morning with the crew to begin movement at about 4:45. So we're in good shape to roll the vehicle over to the launch complex, and we expect to see the vehicle over there about an hour after we roll. The vehicle status, from the standpoint of what we've done for the last 8 months or so, there's been a series of integrated systems testing on the crew module that has built more confidence that it's ready for its operation, and it's got the highest probability of successful launch. So the testing is complete and all passed. The service module, obviously we have a new service module, SM4. It's also gone through the normal build-up processes and testing, and we have high confidence that that vehicle is ready for launch as well. Once those two are completed independently or individually, then we stack those vehicles, the crew module and the service module. They again go through pre-rollout procedures and integrated testing. That's all been completed and good results from that. So over and above all of the normal work that we do to get the vehicle ready, the service module was also outfitted with a series of mitigations to alleviate the repeat of the oxidizers or valve issue. So we have a new service module, we have new valves, we have a new load of propellant, and then additionally, the system has been environmentally enclosed and purged with GN2 to make sure that there's no moisture that gets into the system, which we know is the root cause of the first launch attempt failure. The team consisting of NASA, our suppliers, and Boeing have worked very cooperatively to get to this point and can conclusively prove that we have isolated the cause, and we have the right preventative actions to prevent reoccurrence. Michelle Parker will speak in more details, but there's been a significant amount of testing and root cause analysis that's been performed by the entire team, our suppliers, Boeing and NASA, and we're confident that we have the right mitigation in place. We've also cycled the valves several times. We'll continue to cycle the valves until we get to launch day to boost the confidence that we have a system that's working. Very proud to be able to represent this team. We've learned a lot in the last 8 months. I've learned a lot since joining the program, and we're ready to take the next steps. Michelle Parker was the Chief Engineer for Space and Launch during this period of the troubleshooting and the testing, and has a great deal of knowledge. Today, she's the Vice President and Deputy General Manager of the Space and Launch Division for Boeing, and it's my pleasure to pass the baton over to her.
Thanks, Mark. Kathy and Steve and Joel, thank you. As Mark said, it's really an exciting time here as we head to the launch pad, and we're really glad to be supporting our NASA customer on this really important mission. Others have already said it, but I really can't say enough about how well the team, including Boeing, NASA, and the subs have worked together to get through this time and ensure that we are returning to the pad safely and with all systems ready to go, as Mark described. The spacecraft looks great, it's performing great, and it's ready for its trip out to the VIF tomorrow. The team is also prepared, been rehearsing, they're ready to go, and we're looking forward to a successful mission on the 19th. Just to say a few words on the oxidizer isolation valve issue that we've been working through since our last attempt in August. There's been significant progress. We have been able to narrow down the root cause and put mitigations in place that I'll talk about a bit to ensure that we won't have a repeat of that concern. So we're confident that we've got that surrounded and have the right process in place going forward. If you recall, when we first experienced the issue in August, we immediately set up an integrated investigation team. So that was all team members, NASA-Boeing, and our subs involved to look at all possible causes with the goal of understanding the issue, mitigating it, and returning to the launch pad safely and as efficiently as possible. And I'm glad to be able to say that the team has accomplished this goal and we're ready to go. As you may recall, we followed a rigorous process to ensure that we understood the behavior. We went through a fault tree analysis. We looked at all potential causes, used facts and data to eliminate all of the potential causes until we were able to hone in on the root cause. And so this remains the cause that we talked about in about the October timeframe of this combination within the valve of the nitrogen tetroxide, or the NTO, ambient moisture, and the aluminum housing of the valve. And so you need all three of those aspects to come together in order for the first two, the NTO and the ambient moisture, to react to create nitric acid, which then reacts with the aluminum housing of the valve, causing corrosion products. And those corrosion products then result in preventing the valve motion, which is a very, very small motion, like 30 mils of motion, and just the presence of those corrosion products can hinder that progress. So that's the root cause that we've had. We've completed testing both on and off the vehicle. So we did return the vehicle to the factory. As you know, we did a lot of testing on Service Module 2 with the valves that had experienced this issue to understand the behavior and really hone in on what we were seeing. We've also been able to remove those valves since then and do disassembly of valves that were a valve that was stuck, a valve that was intermittent, and a valve that wasn't stuck. And what we saw within those valves were these corrosion products, as we've mentioned. So we were able to confirm the presence of these products in the way that I just said. We've also done off-vehicle material testing, and we've done off-vehicle valve testing with valves that had not been on the spacecraft at White Sands to confirm the generation of these corrosion products with these three constituents present. And in that testing, also, we have exposed those valves to the environmental conditions that the valves had seen, and also those environmental conditions that we expect to be seen on OFT2, and confirms that our mitigation methods are appropriate. So again, I'll talk a little bit about the mitigation that we've put in place, and Mark has touched on it also. As I mentioned, in order to have this reaction, you need these three components: the NTO, the moisture, that's ambient moisture in the air, and the aluminum housing. Without those three components, you don't get the reaction. So without the moisture, if you can eliminate the moisture from the valves, you won't have this reaction, and it won't lead to corrosion. So we've done a number of things for mitigation, including a dry purge of the valves. So the valves have compartments through which we've got GN2 purging the valves to prevent any moisture from getting into the valves. We've also sealed up a potential moisture path in the electrical connector to ensure that we don't get any ambient humidity through that path. So those two things will prevent the moisture from getting into the valve to start that reaction at all. And then in addition, we've loaded the NTO later. Mark mentioned that the vehicle is loaded, but we did do that later in the flow so that there's less time of exposure of the NTO. And we've added, operationally, we've added cycling of the valves every 2 to 5 days post-load until the time that we launch to ensure that the valves remain operational. So we've been doing that cycling. We've done that successfully. We'll continue to do that. The last cycle will be on the 17th, and then during the nominal countdown launch procedure on the 19th, we'll cycle the valves again. So with all of those items in place, we're confident that we understand the issue with the rigorous investigation that the team has undertaken, the testing that's been completed both on the vehicle and off the vehicle, and the operational controls and mitigations that we've put into place. So lots of credit to the team. There was a lot of work to really go through all of the details and ensure that we've got this nailed. And so lots of credit to the team working closely together. Again, we're proud to support our NASA customer in this major step forward, and we're looking forward to the rollout tomorrow and a successful launch on the 19th. So with that, I'll turn it back to Josh.
Thank you, Michelle, and we'll now turn for the question and answer portion. Our first question today will be from Jeff Faust at Space News.
Hey, good afternoon. A question probably for Michelle Parker. I don't know if I caught everything in terms of the mitigations, but are you doing anything to change the valves themselves, for example, reducing the amount of aluminum in the housing that would be susceptible to corrosion?
Yeah, thanks, Jeff. We have not redesigned the valve at this point. These are the same valves. We have added sealant around the electrical connector, which is the path in which the moisture ingress to the valve, the ambient moisture ingress to the valve. So we've made that change. And then external to the valves, we've put we've put compartments around the valve so that each of the valves can be purged with nitrogen to keep the moisture away from the valve.
And our next question is from Bill Harwood at CBS News.
Yeah, thank you very much. This is probably for Michelle too, I guess. I've always been wondering if there's something unique about the Starliner architecture that you had the problem there when, all rockets, use these propellants and have valves. And I'm just wondering what you might have learned that shed some light on why you guys got stuck with this corrosion issue. And I don't recall things like this on other vehicles in the past. Maybe a dumb question, but I just was curious what insights you might have. Thanks.
Yep, no problem. Well, I'll just point out that we did successfully use these valves on OFT-1, so they were successfully used there and during our SM hot fire test. So we have successfully used the valves. We didn't learn anything specific about the valves other than what I mentioned, that we're sealing this ambient moisture path. There was a path that would allow, if there were humidity in the air, for that humidity to enter into the valve. So we have sealed that path. The migration of NTO through Teflon is a known phenomenon. That is known to occur. It has occurred in other valves. But Teflon is the most appropriate material to use in the presence of NTO. And I would say the one other learning that we've had is the duration of time that we loaded that the NTO was sitting in the vehicle. And so, as I mentioned, we have loaded as late as possible to ensure that we've got a successful launch.
Thanks.
And hey, Bill, these prop iso valves, especially with NTO, that they're like the bane of our existence. So this is something, it is not a new phenomenon on the spacecraft side, but we're learning a lot about this as we're going through our spacecraft.
I would add, Kathy, I would say, from my experience in shuttle, we had problems with oxidizer corrosion, and not specifically in an isolation valve, but with thrusters, and we had to take some mitigations to eliminate moisture and forming iron nitrates and things that caused some valves to stick on the shuttle RCS system. So it's a long-term kind of issue across human spaceflight and other spaceflight, having corrosion in valves with oxidizer exposure to moisture and permeation of the vapor across the Teflon seals, which we know happens. So.
And we've done purge systems. We did the same purge systems, right? So it's to keep anything that's potentially open to the environment, keep that area dry. Same kind of mitigation.
And our next question is from Stephen Clark at Spaceflight Now.
Hi, thanks for doing this. You mentioned no changes, no hardware changes to the valve itself for this mission, just these mitigations. Going forward for future Starliner missions, are you looking at a different valve design? Any changes that you're considering or are currently in work that you plan to introduce somewhere down the line to further reduce the risk of this occurring in the future?
Stephen, maybe I'll take that one. And so we have a usable, as mentioned, we have a usable solution for OFT2. We don't expect to have any issues. As always, we'll look long term and see if there are improvements to be made. As somebody mentioned, the aluminum housing may be one piece of that. But right now, we're confident in the solution that we have going forward, and we'll continue to look at future missions.
And our next question is from Marcia Dunn, the Associated Press.
Yes, hi. One real quick question and one longer one. If everything goes well on time, more or less, when would be the earliest you might expect to fly your first crew? And also, for the Boeing reps, do you have this sense of trying to have to play catch-up here? I mean, I'm assuming it must be frustrating or difficult watching the competition launch crews right and left all the time, and you guys are still waiting to get up and get to the space station. How do you cope with that? How do you deal with it? Is it in your minds at all as you work forward to launch? Thanks.
This is Mark Nappy. I'll take the first part of that question. We have been working the next mission as well as getting ready for OFT2. We have a schedule that supports working throughout this year and then getting in a position where we could potentially be ready by the end of this year. We understand we are going to learn a lot from OFT2. That and many other variables will dictate where the final schedule falls with the launch of the CFT. But right now, we've got a target for the end of this year.
And I think with regard to this is Michelle, with regard to the second part of that question, our focus is really getting to the pad safely, getting through the mission safely, learning as much as we can, and being able to provide a great service to our NASA customer. And that's our focus right now. I think there are a lot of exciting things going on in space, and as space professionals, we're always excited about everything that goes on. We certainly want to be a part of that. We're looking forward to the successful mission, and that's our focus really, is getting to the successful mission and being able to deliver this capability to our customer.
I'll add to that.
Oh, hey, go ahead, Mark. Sorry.
Well, I was just going to add to that. I represent the workforce, and I talk to them frequently, and they're professionals. They understand what we're doing here. This is very difficult to build and develop and launch this type of vehicle. So they're very laser focused on doing this right, and that's really where their minds are. So we're going to do this the safest and with the best quality possible, and when we launch, we launch.
And Marcia, I'd say, this is about a team, right? And so I'm very grateful that Boeing is not and Stitch is not taking any shortcuts. We're doing it, one step at a time. Did extensive testing, made sure we took hardware off vehicles, went and did detailed failure investigation, made sure that we really understood this before teeing vehicles up and bringing them forward into a launch campaign. And so that really showed to me a great deal of maturity and not being in a hurry. And obviously, we're also very grateful that SpaceX is giving us this opportunity to be able to have that time and fly. But these are the kinds of things you got to do when you do human space flight. And I think as a joint team with Boeing and SpaceX, we really, I've been very grateful to both providers operating in this manner and being able to provide this support.
Thank you.
And our next question is from Eric Berger at Ars Technica.
Hi, thanks very much for doing this. Just a quick follow-up on Marsha's question and a second one. These are probably for Kathy or Stitch. Mark mentioned that, they're targeting by the end of the year, but what do you think from NASA's perspective is kind of a minimum amount of time to analyze, data from this flight and clear Starliner? Is it 6 months? Is it less? I've heard it's 12 months. So just some clarification from NASA's perspective on that would be helpful. And then secondly, do you have all the approvals you need from the partners, including Russia, for Starliner to dock with the ISS? I recall this was kind of an issue with the first Dragon mission to ISS. Thanks.
I'll take the first question, and then I'll let Joel take the second question relative to the partnership and allowing OFT2 to dock. In terms of overall schedule for CFT, I think we'll just, as Kathy said, we're taking it one step at a time. Mark and his team are working to have the hardware ready for the CFT vehicle by the end of the calendar year. And then we'll sit down after the flight and review all the data from OFT2 over a number of months, see how the vehicle performed, lay out the schedule for the rest of the certification work, and then we'll select a launch date when the time is right to go fly CFT. Both flights are very important to us, OFT2 and CFT. I know my team's probably tired of hearing me say it, but I think the best path to CFT is a successful OFT2 flight, because really this is the time that the vehicle is put through its paces in the space environment for the complex rendezvous and docking sequence with the navigation sensors on Starliner. And really the only way to test that we've found is in the space environment, also the NASA docking system as well. And so these are big, important steps on the way to CFT. And Joe, I'll let you take the second question.
Hey, thanks, Steve. From an ISS standpoint, we had our stage ops readiness review last week, and everyone pulled go, including our international partners, all the international partners. As Kathy mentioned earlier, we will have the flight readiness review on May 11th, and so it'll be another opportunity where we'll engage management across the agency, as well as one more talk with our international partners, but we're not expecting anything other than a go at this time.
Our next question is from Peter King at CBS News Radio.
Great, thank you, and good afternoon. This is for Michelle or Mark, and assuming everything goes well and the data checks out, how many flights have you got booked for NASA for the ISS and for other clients, or how many do you envision once you're operational?
Hey, this is Mark. I'll start off and see if Michelle wants to add anything. Obviously, we've got the OFT2 mission coming up. We have CFT at the end of the year, and then we have 3 PCM missions that are on contract, post-certification missions, and then there'll be a follow-on after that for PCM 4, 5, and 6 that are not authorized today.
And our next question is from Irene Klotz at Aviation Week.
Hi, for Mark or Michelle, in the process of looking at the issues with the valve, did you find anything else that needed to be addressed on Starliner or any other Boeing programs? And for maybe Steve or Joel, could you just go through the differences between the NASA docking system and the Dragon? Thanks.
Hi, Irene, this is Michelle. I'll take the first one. From the outcome of the valve investigation, we did not find anything else on the vehicle or any other Boeing vehicles that would be, sister issues to the valve issue. We've gone through our normal testing on spacecraft 2, worked through all of that testing, so no major additional findings on spacecraft 2. She's ready to go.
Let's see. I'll take the question on the NASA docking system. I would say fundamentally the Dragon docking system and the NASA docking system are very similar. SpaceX has designed their system to be optimized for the Dragon vehicle in terms of its mass and its performance and speed and velocity, closing rates and so forth to ISS. The NASA docking system is a little